Okay, I'm sharing my screen now. Ashish, let me know whether this screen is visible to you.
Yes, it's visible.
Okay. Good evening, everyone. Welcome to the assignment session 6 on NPTEL course Engineering Hydrology. So today we will be covering the topics which are as follows. Like firstly, we will go through some of the concepts or numerical problems based on infiltration process. Then we will try to understand about the abstraction process, then infiltration indices that there are two major infiltration indices are there, phi index and W index. So based on this aspect we will be solving some numericals. Then we will also look into the factor that is effective rainfall, that is one of the important parameter for generating the direct runoff in any watershed or catchment. Then further we will try to look some of the numericals uh, based on the infiltration empirical equation, though we have covered uh, Horton's equation in this case, but yes, still there was a few more empirical equations, so we will be going into this. Then numericals on the infiltration indices, we are looking into it. Okay, so today the session will start from the numerical question only. So you can see there is a question which is asking that we have to determine the parameter of Phillips equation. Yes, so this Phillips equation, we know that this is an empirical equation for computing the infiltration rate in any catchment. So for this question we have been provided the field data. So what they are measuring, they are computing the cumulative infiltration depth. They are recording this data with the variation of time. So definitely there will be a stopwatch in the field, they will be computing this, and then at the same time they will be having uh, any kind of infiltration instrument, like there could be a single type infiltrometer or maybe a double ring infiltrometer. So based on that aspect, data have been recorded. Now we have to quantify the parameters of Phillips equation. So firstly, I want to ask that what are those parameters? Firstly, we should know that what are those parameters. Then only we can quantify them. So kindly let me know. There are two major parameters. Like in similar fashion, we already discussed about the Horton's equation, right? So Horton's equation, how many parameters were there? Like those are the parameters for which we don't have the value right now. So at that case, we will be trying to compute the parameters. Like unknown parameter were majorly a k value, that is a constant.
Yes.
Another one is what?
MX,
Mx.
uh,
But you should figure it out in terms of equation, right? So there will.
FC, FC, and F naught.
So kindly let me know the equation again. So Fc plus, what is
So
the difference?
FC,
F naught minus Fc e to the
yes, F
power
naught
minus
minus
Kt,
KT. Yeah.
right? So what are the unknown parameters here?
F naught minus FC.
Yes, in some of the cases, what we are known with. So definitely, when the we are recording the field data, we come up with this factor, that is a constant infiltration rate. That is, we can also term it as like maximum infiltration capacity which
Hmm.
soil can hold. Okay, so this is a Fc value, that is a constant. Like there will be a uh, because every soil porous media, it will having it can't be a buffer kind of thing, like there won't be an infinite volume storage in a specific volume of soil. So definitely there will be a finite volume, we can say.
Oh.
So for that case there will be a constant infiltration rate. So that is why we are getting this value FC. So we know the FC value. We also know that with the passage of time how the infiltration rate is going on. So FT is provided, but still we have to look it into this part, F naught, as well as the K value. And
Hmm.
I already mentioned that K is representing the soil condition. Like
Hmm.
soil condition may be related to a texture, right? It may be related to a texture. It may be representing moisture content in that case, right? Moisture content will also be there. So Ashish, you got that K and as well as F naught. These are the unknown parameter. Now in similar fashion, there is a Phillips equation. We all you have to tell me that equation, that how we are writing that. What is the form of that?
Mm, FT.
So you may be knowing there is a Phillips equation. So definitely there are two major parameters involved. That is one of them is sorptivity,
Sorptivity or
right? That is
conductivity.
representing the suction potential of the soil content, suction
Hmm.
potential, right?
Hmm.
So that is one of the parameter. Then another one is hydraulic conductivity, saturated
Hmm.
hydraulic conductivity, right? That
Oh.
is a parameter from Darcy equation as well, right? Do you remember? K is a parameter of
Hmm.
Darcy equation, Darcy law,
Hmm. Correct.
right?
Hmm.
So we have to quantify these parameters. So Ashish, just I want to from field perspective, I want to like bring attention into this model, that you have to see that though we have various instruments for computing the hydraulic conductivity, but just performing the infiltration test in the field, we are directly getting the value of hydraulic conductivity now. Can you tell me what are the methods for by which we can compute hydraulic conductivity? Do you have any idea what are those methods?
One is the experimental method.
Aha, experimental, name that.
That is a double ring and single ring
No,
infiltrometer.
no, no. This is a part of infiltration. This is a part of infiltration test only, right? I'm just asking that there are some field. There are some instrument setup, okay, by which we can get the direct value of K. Okay. So for that case, I want to mention there are two methods. One is constant head pyranometer. Okay, this is for your
Okay.
information only. So
Hmm.
constant head pyranometer. So you can find it any of the lab, like if it is related to you can find it from geotechnical lab also, right? You can
Hmm.
find it easily, because they also used to perform saturated hydraulic conductivity, because this parameter is important while they are designing any kind of flexible or rigid kind of pavement, right? So they have to know the importance that what is the saturated hydraulic conductivity existing in that soil media. So constant head pyranometer is there. Then one more is that is a variable head pyranometer. Okay. So but here we are getting this value directly without using any kind of instrument, and it will be a more accurate as compared to these instruments. That is also one of the advantage, because you are getting a direct value from the field. Okay. Now how we can compute this? So tell me the equation, that how this Phillips equation is written.
So S T to the power half, I think.
So 1 by 2, right?
0.5 S
S
T to the power minus 1 by 2.
t to the power minus 0.5. Then
Yeah.
there will be a constant
Plus
as well,
KT. Plus KT, I think.
plus kt. Okay, good. So K is here a hydraulic conductivity. Balamurgan, are you getting the things? Ma'am, are you also getting the things? Like, are
I was,
you able to get what we are discussing?
yeah, I'm following.
Okay, yeah, thank you. Okay, Ashish, so you are right. So this is the form of equation that Phillips had derived based on his experimental setup. Now we want to compute S as well as K. So tell me, what are the things we already have? Like, what are the input parameters we already have? We have in the data itself. So one is
One is time
FP.
we have. Yes.
FP we are getting, though it is not a FP. Here they have provided a capital FP, right? Don't
Hmm.
confuse with this, because this is a cumulative infiltration depth.
Hmm.
Cumulative infiltration depth can also only be get while if we integrate a infiltration
Rate.
depth, yes, right, infiltration rate at a given interval of time. So if
Hmm.
we are having T1 to T2, so if we integrate it, we will get this cumulative infiltration depth. But now they are providing this value, but we have to break it down. We have to break it in terms of FP. So what we will do, we will only take out the incremental value.
Yes, yes,
Okay,
yes.
so we will get this value FP. So based
Hmm.
on the incremental depth, we will be getting FP. So FP value we already have. Now now remaining is what? So T. Okay, so T also we have. So can you tell me what could be the approach? Like, I just want to know that, like, based on the Hortons, you can compare the things.
Hmm.
There is nothing deviating a lot,
Sure.
right?
So, okay. So first we have to convert the time minutes into hours,
Yes, that's good. So T, you
and
are saying that it is given in minutes, so we are computing in hours, right? That is good
hours.
point.
Yeah. Second is we have to make one separate column for the incremental time and
Good.
the incremental depth.
Okay. So incremental depth you are saying, and you are also saying that we should compute the particular
In,
interval, right?
yeah, incremental time. Yeah, sure.
Yes. Good. Then,
Then we divide the incremental depth with incremental time. We get the infiltration rate.
okay. If we what you are saying? Okay. What you are saying? Just repeat it.
We divide incremental depth with respect to time. Then we get the infiltration rate.
Okay, but why do we need that? Because okay, that's good. Yes, yes, yes. Incremental infiltration rate, right?
Yes, yes, incremental.
Good. That's good. Then again,
So
incremental
from this we get
infiltration
the
rate. We
value
got
of
it. So this is a FP value, right? You are right.
yes, FP,
Good.
yes.
Now we also have T value in hours. We can plot it easily. There is no problem
Hmm.
now. Now, Ashish, we have to plot this data, right? We have to plot this data first. Now, one more thing I want to say. Though this equation has two unknown values, so definitely we are unable to solve this directly, right? So now is still the problem is still exists. Okay, so for that case, in order to simplify this, we what we will do, we will be taking the plot of FP versus T,
Time.
right?
Hmm.
But here we are taking not T, we will be taking directly a T to the power minus 0.5. It will make the things easy because we can directly convert this equation in form of y equal to mx plus c. Got it?
Yes.
Okay. Now we will be looking into the graph now. So come. So Ashish, you are right. You mentioned everything correctly. So in this column, you can say see. So in the column number 4, we have computed the incremental infiltration rate now. Then we have also converted the time that was given in minutes to into hours now, and we have also computed T value in the power of minus 0.5. Now we are going to plot this graph. Okay, now you can see that the graph have been plotted between fp as well as t to the power minus 0.5, and what you see the result that these points are approximately lying in a linear profiling, okay, because a straight line is fitting this line with r square value 0.97. That means 97% uh, linearity have been shown by these plotted points. Got it? So equation,
Mhm.
now you can focus on this equation. Ashish, you can already from graph itself, or maybe uh, by using any kind of Excel plotting, you can get this graph easily. Okay, any
Okay.
difficulty till now?
No, no, not yet.
Okay, now correlate this equation with Phillips equation. Here you can find this Phillips equation. Now tell me
Yes,
the
so
parameters values.
K is 1.23.
Got it. Yes, K is 1.23 directly. You got this value. Good. Then
Then by 3.
then you have to compare this value, whatever m value is coming, like
Okay,
slope.
okay. Yes, yes, yes. This is M.
So m slope is coming how much?
Two
3.2287,
two eight seven.
and we
Yeah.
have to equate it with half of s. So we have to only multiply this 2 with 3.22. So approximately it will come how much? It will come 6.4 on something, right? Got it? So this will be a S value, and S is what? That is a function of soil suction potential. So this is somehow representing a data that we usually get while we are performing a test called you can say capillarity action kind of instrument that is related. Yes. So we usually perform that, and we try to get this data. Even there are some more instruments for finding the sorptivity. That is a suction head. That is one of them is pressure plate test is also there. We usually perform certain such kind of test in our laboratory. So pressure plate test is also here. So based on this instrument we can get this S value, but still the thing is, if we are getting this parameter values by knowing a field data, that will give you more accurate value as compared to what we are getting from the like instruments. Okay, because the thing is like a field kind of scenario data will be more uh, associated to the field conditions, right? But whenever we bring the sample and we try to perform it in our lab, definitely environment conditions which are existing in the field will be deviating in the laboratory. Okay, should we move ahead now?
Yeah, we just please go back. We the S value 2 into 3.2287. Multiply it by 2 because there is upside is half.
Yes, yes, yes.
Okay, got
So
it.
half we are multiplying it now, na?
2 give okay, 2 the
Yes,
best probability equation.
exactly.
Okay.
So we are multiplying 2 with 3.22. Then
Mm-hmm.
only we will get na S value. Otherwise, how we can compute?
Mm-hmm. Correct.
Got it? Because
Got it.
m is entirely a S by 2 value. That is you
Mm-hmm.
have to keep in mind.
Mm-hmm.
What we are doing, we are taking t to the power minus 1 by 2 as you can say x, and we are taking fp as y. Now remaining what? Half of s will
Yes.
be m only, and
Yes.
remaining k will be c, right?
Got it. Got it.
Got it? Yeah. Now the question based on some theoretical aspect, we should have some idea regarding infiltration rate. So here it is asking that what are the factors which can influence the infiltration rate. So think about the field kind of situation,
Mm.
and try to figure out what could be the possible options which can
So
affect the infiltration rate.
so
And I also
porosity.
want to know that like there should be some valid reason behind selection. Tell
Yes.
me.
Okay. One is porosity.
Ha, that's good.
Yeah.
How you are saying that porosity will have
If
effect in infiltration
there
rate?
is more void space available, so you get the more infiltration rate.
Yes, good.
Then hydraulic conductivity.
Okay, hydraulic conductivity, good.
Then I think moisture content also.
Moisture content, yes, moisture content will also have role. Good.
Yes.
Then,
Yeah, that's all I think.
okay. So you are right, but at the same time, I also want you to pay attention in this, that if you are talking about the porosity, so porosity will definitely get influenced when texture is changing. Got it?
Hmm.
If we are changing a texture of the soil, okay, so definitely porosity will be changing. Now coming to the hydraulic conductivity, so here also the texture will play a significant role.
Hmm.
Now, can you relate infiltration rate with vegetation cover as well? If
Yes,
we
definitely. That also matters. Condition of the soil surface and land use, vegetation cover also influences infiltration.
exactly, yes, yes, you are right, ma'am. That LULC, land use land cover. So just for the curiosity, I want to just ask that if we are having urban land, okay, urban land we are having, and then another place we are having a vegetative land, like for example, you can say a forest is here, or maybe an agricultural land is here. Then can we what could be your like observation where we will get more infiltration?
The forest.
Yes, you are right, ma'am. So definitely, forest will be having more infiltration as compared to urban, because urban definitely there are concrete kind of structures. Whatever the rainfall is coming, it is directly falling over the surface, and it is not infiltrating anymore. Like you can say, like 0.001% is infiltrating, but remaining part is contributing as a direct runoff, and because of that we usually see a problem of water logging in case of urban areas, right? Ashish, got it?
Yes, yes, yes.
Okay, so we can see the explanation now. So here the factors which can influence the infiltration rate. So you can see that characteristics of the soil that I have just mentioned, that texture will definitely have a crucial role in this case. Like for this, I have just added one picture. So you can see that infiltration capacity rate for this dry sandy loam is more higher as compared to wet clay loam. Okay, so you can have some differentiation in your mind that yes, if we are having a sandy kind of soil texture, then definitely it will be having more infiltration as compared to clay. Got it, Ashish? Any confusion here?
No, no, no confusion.
Okay, so you are right that condition of the soil surface is also important, because if it is completely dry, or if it is completely wet, then definitely it is having influence in the infiltration rate. Then current moisture level, yes, of course. If there is any kind of seepage, or maybe a water source is influencing our target area where we are performing our experiment, if there is any kind of water is seeping into that area, definitely it will be having effect in the infiltration, actual infiltration rate. Then again, vegetation cover, yes, and then soil temperature also plays a crucial role in this. Now coming to the question, so it is asking that the difference between the observed total rainfall hydrograph and the excess rainfall hydrograph is termed as. So you may be remembering one picture, that intensity versus uh, this time graph. Okay, hydrograph is this only, right? Am I right or wrong? What is
Right.
hydrograph?
The rainfall intensity versus time.
Exactly. So like this will be plotted in kind of this bar chart, right? So we could be having bar kind of like column kind of graph we can acquire after plotting this intensity versus time graph. Okay, okay,
Mhm.
so from this graph you can see there are columns which are representing that how with the passage of time intensity, how the intensity is varying in any targeted area. So now it is asking that difference between the observed total rainfall hydrograph. So whatever I have plotted, it is a total rainfall hydrograph only. Okay, it is a total rainfall hydrograph, but how, when I can achieve excess rainfall hydrograph, can anyone tell? When can I achieve excess rainfall? Or you can also explain that what is meant by excess rainfall hydrograph, why we are calling excess rainfall hydrograph, what does it mean?
When the soil is wet,
Yeah.
whatever flows as runoff is meant as excess rainfall, is it?
Yes. So right, one more thing is that excess rainfall will be achieved in any area when we subtract the total rainfall with infiltration. How much infiltration depths have or infiltration have occurred in that region. If we subtract the total rainfall with the infiltration, then the remaining part will be draining over the land only. It will be draining at the land. So whatever the runoff depth we are getting, that is the part of total rainfall only, but it can now termed as excess rainfall. That yes, this much of excess rainfall is not going beneath the subsurface zone or beneath the ground surface. Instead, it is generating a surface or direct runoff. It is generating a direct runoff. So for that case only you have studied some of the indices, right? If you remember, for subtracting, for quantifying this infiltration, we have uh, we have studied two major infiltration indices. One is phi index, and then another one is W index. We have studied these. So if we know that for this area phi is known to me, if I know that phi is known to me, so I know that this is entirely a total rainfall hydrograph, then I know that yes, this much of infiltration is happening. Now if we see the upper portion of phi, like above part of this dotted line, so this is contributing to excess rainfall only, excess rainfall. So now you can see that this question is asking that difference between the observed total rainfall hydrograph and the excess rainfall. So this is excess part and this is a total part. So what it is asking? It is asking about this area, right? Whatever like below part of dashed line. Got it? Ashish, what could be the options now?
So abstraction.
Okay, yes, abstractions, yeah, you are right. So definitely abstractions as well as losses also. So here, why
Both.
we are, yes, why we are counting abstractions? So definitely, you can say
Depression storage or something like that. Then
yes,
only that also has to
exactly.
be included, right?
Right. So abstraction will come into that picture. And then if you talk about losses, so you can also count that yes, infiltration have been occurred, or evapotranspiration or evaporation process is also there. So water is going out of the system now. It is not uh, conserved in that system, I can say. Okay, so for explanation part, you can see that all abstraction from the precipitation, those due to evaporation, transpiration, infiltration, surface detention, that is a depression only. So they all will be counted in subtracting, like in terms of abstraction and losses. Okay, this is the picture that I have just added for the reference that yes, excess rainfall will be contributing a runoff. Now coming to the next question. So rainfall hydrograph shows the variation of which of the following? So it is just asking what is meant by rainfall hydrograph.
So it's rainfall intensity with respect to time.
Yes. So rainfall intensity with respect to time. You are right. So there should not be any kind of discussion needed in this. Okay. So you know that a hydrograph is a plot of intensity of rainfall against the time interval. Can you tell me that how we can get the this intensity? If we have rain gauge data, we already discussed this. If we have rain gauge data and we are plotting a cumulative rainfall depth, okay, we are plotting a cumulative, that is summation of p, I can say, with respect to time. So what kind of curve we are getting? Can you name that
Mass
curve?
mass curve.
Yes, mass curve. So it was mass curve, right? Now I just want to know how can I get intensity from this curve? Intensity, you know the unit of intensity is centimeter per hour or maybe centimeter per day. Now from this mass curve, how can I get the intensity?
So we can subtract from last time interval to proceeding time interval and then divide it by the time interval of time. We get the intensity.
Ha, you are right. You are following the same thing, but just I am asking from the graph only. So if we are having mass curve like this, so if we take, like if you are plotting this graph in Excel or any kind of like handwork, so by just taking the difference, like just taking the slope in this graph, we can directly get the intensity. Okay,
Okay.
because cumulative this summation p, it will give you some delta p value, and you can also get some delta t value, and if you take the like uh, ratio of delta p by delta t, you can directly get the intensity value, right? Just for your revision only, I just mentioned this, you already know. Okay, now the next question is, surface runoff represent total water. Okay, so it is asking about, we are having ground surface, rainfall is occurring somewhere, and now surface runoff is happening. Now we have to say that how this surface runoff is occurring. Okay,
Yeah. So
what could be the
obtained
answer?
after deducting from rainfall water what has inflated or evaporated. Second
Okay,
option.
yes, good. Then can you tell me like any other option can be there? Like just I am asking because just for confidence, your confidence only, I am just asking. Ma'am, what is your thought on this?
I also felt too, but it also is can be related to the fourth one, which takes place after a specified period of time.
Okay, good. Then Ashish, can you tell me Bala Murugan has replied anything?
Yeah, he replied second option.
Okay, second option. Good. So, yes, you all are correct. Second option is right, but definitely there may be confusion related to first, then fourth option as well, because it is also saying that whatever the water is falling or maybe flowing through the channel, it can also contribute as a surface runoff, right? But yes, just it is related to the flow. Okay, but it is just asking that surface runoff in terms of total water. So total water is what?
Representation, volume, right,
Precipitation,
volume.
yes. So whatever the abstraction will be there, after detecting the abstraction, whatever the water is flowing, whatever the water is just flowing, like flowing in the sense, it doesn't mean that what are their sources. It is not asking about the sources. Like sources could be anything, like yes, definitely there will be a surface channel, maybe whatever the water is getting infiltrated, okay, and it is contributing as a base flow also, and it can also return finally at some location, and it can also contribute as a surface runoff, definitely. But yes, this time it is not asking about the sources, it is just asking a general sense that surface runoff represent total water. So in terms
Quantity.
of yes, in terms of precipitation, how is it, how we can say our uh, like what could be our conclusion in this. So just for your information, surface runoff represent the total water obtained after deducting this rainfall, what has infiltrated, evaporated from the total runoff, total rainfall. So total rainfall is P here, and losses. So losses could be anything, if, water that has been stored, or maybe water that has been uh, transpired, or maybe evaporated back to the system after the system. Then you can also see that flow in this mode. Now it is asking about, it is saying about the flow. Okay, so flow is what, that it travels all the time over the surface as a overland flow and through the channel as open channel flow and reaches the catchment outlet. So when we are talking about the flow, then definitely what would be the possible sources it can go. Now you can see that different routes of runoff. So different routes of runoff is, you can see, first is overland flow. Overland flow will be the more dominating parameter in generating the direct runoff. Then again, you can't say that groundwater cannot reach over the surface. Definitely, you through the base flow, it can also add up into a certain kind of stream. So there could be many pathways for the water to come out of the surface, subsurface. Now coming to the next question. So fundamental hypothesis in the SCS-CN method is. So firstly I want to know that have you studied this concept SCS-CN curve method at present? I'm just asking that have you studied this topic in your videos, lecture videos?
Yes. Yes.
Okay, that's good. Then it won't be a problem now. Can you tell me what is meant by CN?
Curve number.
Good. And what is its range? There is some range where CN varies.
Yeah, Mr.
It should.
Balamurugan replied 0 to 100.
Ah, that's good. Yes, Balamurugan, you are right. 0 to 100. Now I also want to know what is the significance of 0. If we are saying that in any catchment we are getting curve number 0 or we are getting curve number as 100, what does it mean? Any comment on this?
He says 100 is a water body.
Okay, yes. And if we are having 0, then definitely water body in the sense, yes, surplus amount of water is there. Exactly. And then if we are saying that 0 is coming, then definitely there is a impervious kind of,
Impervious surface. Impervious
yes,
surface.
right ma'am, you are right. So impervious surface will exist. So usually whenever we are we try to compute surface runoff in case of you can say urban area, okay, usually curve number less than 30 usually come, usually followed, okay. This is not a standard value, but definitely like varying with the field problems, definitely curve number will be low as much as possible. But if we are saying that curve number is nearly to 80 to 90, so you can say that surface definitely there is a major portion of water which is retained in the soil, or maybe yes, definitely in the soil itself, that will be counted. Now there is a concept SCN-CN curve method. Now it is asking about the fundamental hypothesis. So before deriving the final concept, final equation based on the curve number, there was some assumptions involved, okay, in terms of ratio only. So you have to tell what is that assumption. Ashish, any input in this case?
Balamurgan says the second is the correct.
Okay, the ratio of actual retention. So he is saying that actual retention, if I say, so for this case F I say, then potential maximum. What is meant by potential maximum retention? What is the parameter we called this? Potential maximum retention. How we are representing this parameter?
I think one is correct.
I will discuss it, but firstly let me know the parameters name. Firstly, potential maximum retention, if it is saying that what how we are representing this parameter. There are some certain kind of parameters, you know, that P, there may be IA also there may be S also there, okay. There are some parameters F, you can also say that Q may be also there. So now I just want to know that which parameter, like what is the representation of potential maximum retention? Any idea?
I think.
Like you can see ratio of direct runoff.
Potential is one. Beyond, I mean, after from rainfall, when you subtract initial abstraction, what is the remaining is potential uh, RO.
Yes. You are right, ma'am. Just I'm asking the abbreviation of that. Like you may be remembering one equation, right? In terms of ratio. So there may be a equation P minus IA, okay, F by S, and maybe if I'm not wrong, so okay, so it will be just a reverse of this P
I
minus
think it's
IA.
the other way. ER by P minus IA is
Q,
equal to FA by S.
okay, Q upon P minus IA. Am I right? This is right. Q upon P minus IA, like a direct runoff to potential rainfall minus abstraction. And then at the right hand side, you will have,
Infiltration.
yes,
Infiltration.
exactly, 2S. S is what? Just I am asking that this is potential maximum retention. S is
Potential retention.
exactly. So I was just asking about this parameter. So now what we are saying that actual retention of the rainfall. So actual retention of the rainfall is represented by this parameter F. Maybe abbreviation may be different from your case, like you may have a different representation of these parameters. We will be seeing this. We will also see that which option is correct. At present I can say this first option is right, okay. Let's see. So firstly we will be looking into SCS-CN curve method. So it is based on the water balance equation. From this picture you can see that
आप मंगल मैं तो
we are
send
having the precipitation rate which is varying with the time. Now we can divide this this entire graph, or you can say infiltration rate versus time graph, in different hydrological processes. Like one of this process is what? That is an initial abstraction. So initial abstraction, which is before the ponding. Why I'm calling it as before ponding? Because at first when a rainfall at any kind of any area, okay, initially this whatever the soil is here, it will be completely dry, right? It will be completely dry. So definitely moisture is not here. So now this soil will firstly accommodate a certain amount of rainfall for fulfilling this moisture, missing moisture, what it can withhold, maximum it can withhold, okay. So uh, this initial abstraction before ponding, for which no runoff will occur, whatever the rain is falling, it is completely going infiltrated. So that is why we are calling it as IA. Then coming to the next, so we are having further infiltration now. Firstly, what infiltration have been counted? It has been counted to fulfill the voids, to fulfill the dryness, or maybe to fulfill the missing moisture in those soil. Like you know that there are many forces acting on, like capillary forces are there, surface tension forces are there, or like cohesion forces are also there. So these forces are dominating by within the particle to particle, it also act. So when the water is coming, they all have capacity to absorb this water instead to let it pass. So this entire water is getting absorbed over the particle surface. So that is why initial abstraction have been counted. But once this particle has taken surplus amount of water over its surface, it will allow further water, further rainwater which is getting infiltrated to pass on to further depth. Now that infiltration will be counted in this cumulative infiltration excluding IA. Why excluding IA? Because IA have been already counted in separate parameter. So now further infiltration which will be occurring, okay, that will be counted as cumulative infiltration. Now if we subtract FA with total precipitation which have been occurred, we will be getting PE direct value. PE is what? Excess rainfall. That excess rainfall will be contributing now as a runoff. Got it? So here we are representing total rainfall as excess rainfall. This is an excess rainfall which is generating a surface runoff. IA, that is an initial abstraction for just fulfilling the moisture condition at dry state, and then further infiltration what will occur in the soil region. Okay, so that infiltration will be covered as FA. So you will be having a clear picture that how total rainfall is getting distributed in the soil region, okay, or the soil layer. So in order to come up and quantify the Q value, okay, SCS-CN curve method was proposed. Okay, so the target was what? We want to compute the direct runoff. Okay, so they did considering this curve number. So curve number is what? This is a dimensionless parameter. Okay, dimensionless parameter, and this parameter depends on various factors, like one you may have studied that AMC is there, antecedent moisture condition. Then another one is LULC is also there. Okay, then soil type factor will also be accounted. So considering these factors, or one more, like if we are counting the soil type as well as LULC, infiltration can be decided now. Okay, so based on these parameters, CN is decided. So using this CN, Q have been derived. But what is the basic assumption that was involved? So you can see that this is the ratio of actual amount of direct runoff. So Q upon P minus IA. P minus IA, you will be getting a direct idea that yes, if we are subtracting IA with precipitation, we are getting a excess PE, that is excess rainfall. Now it will be equivalent to ratio of actual infiltration, so we are calling it as F, to the potential maximum retention, so this is S. Got it? So now you could have like your answer in your mind, that first one was right. This was the first option, that ratio of actual retention of the rainfall to the potential maximum retention is equal to the ratio of direct runoff to the potential rainfall minus initial abstraction. Got it? Shall I move ahead?
Yes.
Okay. For your information only. There is second assumption also there, which defines the initial abstraction. Okay, and what they have justified, that initial abstraction is always 20% of maximum retention. Okay, so 20% of S. So to represent 20, this is not gamma, this is a lambda. Okay, lambda, you may be knowing that. So IA is lambda S, and lambda is what? 0.2. We always count it. So always 20% of maximum retention. Maximum retention in what sense? Like you can see here that parameter S represent the potential maximum retention, depends on soil, vegetation, land, use of complex, where antecedent soil moisture condition in the catchment just prior to the commencement of rainfall event. Okay, so it is just saying that yes, maximum moisture which can be existing in the soil, vegetation, land, okay, just before the commencement of rainfall event. So you can see that after using this 1 and 2 assumption, this SES-CN method have come up with Q to compute direct value. This is a direct runoff value. Okay, now just one more line, that there is one more empirical approach which have been given by SES-CN method. So how we are computing, how we can compute maximum retention. So maximum retention is like what? That is S. So S is dependent, like they have given an empirical formula to quantify maximum retention based on curve number. So this curve number was introduced in order to compute maximum retention. Maximum retention which can be occurred in the soil, vegetation, land. Okay, we will be discussing further. Now based on this only, there is a numerical problem. I want you to go through it. So it is saying that using the SES-CN method, we have to compute the runoff. Okay, daily runoff we have to compute. So it is directly asking about Q. But what they have provided, they have given us CN value. CN is 80. So you will be having idea, clear picture that yes, like a finite water is available for plants as well as the soil. Now it is also saying that rainfall in a single day. So you can see P has been found as 120 mm. Got it? So tell me the approach now. We want to quantify runoff. We have been provided with P. Okay, that is a total precipitation. Total rainfall. Then curve number is also here with us. Tell me the approach, that how SES-CN method can be applicable and we can quantify Q. I want to know what are the relevant formulas which we can go through. Ashish, any idea regarding this?
No.
No idea. Okay. Just now in the previous slide, I just mentioned one formula. This.
Okay.
Like
Q.
after considering the two assumptions, SES-CN method derived this empirical formula. Okay. So Q dependent on P. P means what? That is a total rainfall.
Rainfall.
Then IA initial abstraction. Then S value is also here. That is maximum retention. Soil maximum moisture retention. So now tell me that why CN number is given. What is the use of CN? Why we are provided with the CN number? There are many big tables are there. You may have gone through those tables also. for the AMC, that is antecedent moisture condition,
Mhm.
that moisture condition vary with the dry condition as well as the wet condition. That means a summer as well as a monsoon condition. Then you may have also idea about soil group. Okay, soil group in the sense A to D. Okay,
Mhm.
there are
Correct.
some conditions that yes, group A soil will be having this kind of infiltration capacity or moisture holding capacity. Then at the same time LULC factor is also here. So LULC in the sense that if we are saying that urban area is there, then definitely forest cover may be there, then water body can be there. So based on this LULC, it is also affecting the CN. So after clubbing these three aspects together, CN value can be found. But for saving our time, CN value have been already given here. So we don't need to look after these tables in order to correlate and try to figure out the CN value. So now CN is already given. But CN is given for what? It is given for computing the S value. Just I mentioned in the previous question that for computing this S value, you need input input parameter, that is CN. Okay,
Mhm.
so one thing you got clear that if we have CN in our thought, then definitely S can be computed now. So you can see in the previous formula that is given here. So Q can be found out P minus IA to the whole square, that is P minus IA plus S, right?
Mhm.
So now you can compute S directly now using the CN value. Okay, I will show you the formula in next slide. You already got P value, got it, right? Q
Mhm.
you already
Yes.
have, that is 120 mm.
Yes.
Now you already have S value also. Now if we have S value, can we quantify IA? Can we quantify IA? I just mentioned in the previous question itself. We can compute IA using like value of potential maximum retention.
Lambda is.
Yes, lambda s, and I just mentioned that lambda is nothing, it is a 20% of s. Okay, so 20% of s, so that means if we got value of s, we will take 20% of that, and definitely that will be giving us IEA value. Okay, so what is remaining now? Nothing is. Okay, so
Mhm.
what we need to compute is s value.
Mhm.
So
Yes.
Ashish, any idea that how we can compute s value? How we can compute s value? So for your information only, there is formula called S equal 1000 upon Cn minus 10. Look at this. But keep in mind that this formula will only work when we are considering all the like I'm just saying that okay, S we are getting here, that is 2.5. Okay, what I'm just saying that S will be coming directly in terms of inch. Don't confuse with this, because there is one more formula based on 250. I guess I don't remember right now. Okay, in like multiplication of 250, there is one more formula that will directly give you S in terms of mm, because this factor was multiplied only to convert this inch to directly to mm only. That is why you can see
Mhm.
why I am just saying that 254, it is not 250, it is 254, because 25.4 if we are divided, we are getting this in directly inches. So to convert in reverse process, we can, if we multiply this, we can convert we can directly get the value in mm. So now
Mhm.
Ashish, you have to compute this value and tell me what you are getting. Tell me the
Yeah.
s value.
We got to 2.5.
Okay, good. So 2.5 inch you are getting. Ma'am,
Mm, yes.
are you also getting the same thing? Same
Yes, yes, I got 2.5.
okay. So
Now we can
2.5 is
calculate IEA, right?
ha yes. Now you have to compute IEA value. Yes. So tell me IEA value, how much we are getting?
Point 0.5.
Okay, so you can see that it is already written in the direct formula 0.2 into S. That is nothing, it is a IEA only. There should not be any confusion to you all. Okay,
Hmm.
got it? One more thing, don't confuse with this formula, that is P plus, P minus IEA plus S. And now what I just mentioned, that IA is what? IA is nothing but it is 0.2 into S plus S. Now if we solve this, we will directly get the value of 0.8 into S. Am I
Okay.
right?
Got it. Got
Is
it.
it right or wrong? So there should not be any confusion with the formula now. Okay. So that is why you are not seeing IA like specific abbreviation like IA, okay? Because it has been already incorporated in that in this formula directly. So now try to compute. You already got the S value, you already got the IEA value also. Now all these units were in inches. Now to convert
Hmm.
mm in inch, mm in the sense what? Total rainfall. Total rainfall we have, that is 120 mm, and you have to convert this in inches. So we have to divide it by a factor called 25.4. For mm to inch, we have to divide it by 1 upon 25.4. Then we can get the inch value. See, is it coming or not? Balamurgan, Ashish, you can tell
Yeah,
me if
yeah,
you.
I'm calculating. Yeah, I got 2.653 inches.
2.653 inches. Good. That's good. You
Then
can
I
now convert in
20,
again.
yeah,
You have to
25.4,
multiply with
67
25.4.
point, yeah, 67.4 mm.
Okay,
Correct.
okay.
0.39.
Ma'am, what about you? Like, are you getting?
Just a minute, just a minute. I'm calculating.
Okay, okay. Meanwhile, Ashish, you can also tell me the response from Balamurgan also.
Sure.
Yeah, I got it. 2.653.
Okay, that's good. Now you have to multiply with 25.4 because we need answer in mm. So you can see what could be the answer now. You can say in options. Which option is correct now? This fourth option, right?
67.3.
Yes.
4.
So fourth
3.
option is correct. Okay, now we are moving to the next question. Let me see. Okay. Balamurgan, condition that P is greater than IA. Ha, yes, you're right. Exactly. Because if we are taking less than, then definitely it will be having different outcome. IA this I got for okay 67. Good. Balamurgan, you are doing good. to the presentation now. Okay. So now the next question is related to hydrograph. So firstly, before going to this, I want to know what you understand by hydrograph. So from the name itself, you will be clear that there could be some kind of graph itself, right? So definitely it will be a 2D graph. Now tell me what you know about hydrograph. Firstly, we have to know this. Otherwise, it won't make sense.
Yeah, it's intensity versus time, I think.
No.
The
Runoff against time.
runoff against time.
Yes, you're right. So runoff is that will be measured in terms of discharge. Okay. So here discharge versus time, because whenever we are saying that runoff is there, then definitely to quantify it we have to measure discharge. So discharge is nothing, it is just a ratio of volume of water collected over a certain interval of time. And you know the unit also, discharge unit is always meter cube per second. Don't confuse with this, okay? Because volume unit will be meter cube and T will be in seconds. So discharge versus time, whenever we are saying that the graph between discharge versus time, it will be called as hydrograph. Okay. Now can you like can you have your thoughts that what would be what will be the possible shape of this graph, like if we recall hydrograph, then definitely those are the rectangular columns, right? Rectangular columns which are representing intensity versus time. Now just for this case hydrograph, how will it look like?
It's a curve type graph.
A bell shaped curve.
Yes, you are right. So bell shaped curve, definitely. So it will be having a structure like this. Okay. Okay. So now whatever the variation, if I take a like watershed kind of thing, and it is having streams like this, and now I am having one outlet, okay, and that outlet is a gauging point where I am measuring the discharge now. So as soon as the water like rainfall start in this rain is falling over this basin, this water whatever there will start draining, okay, and it will start acting it will be draining as a overland flow, okay, and from the tributaries it will be meeting to the main stream first, okay, and then like you can take an example of Ganga and its tributaries. Like if there is Ganga, Yamuna is there, then some other rivers are also there, then whatever the basin area it is covering, it is draining this point and meeting it to the main river. This is the main Ganga, and then again it is taking that this water and it is finally disposing its water in the sea, in the sea, okay, by forming a delta kind of thing. So here also we can make a discharge, we can measure the discharge measurement, here also we can make a discharge measurement, okay, and that is the thing it is being given. So what I am just saying is that as soon as the water start falling in over the basin, this water will start accumulating and contributing as an overland flow and finally reaching to the outlet. So you will be seeing that rising curve, okay. Once the rain is now the rain is receding, like it is now stopping now. So now the remaining amount of water which have been maybe stored in the soil moisture, or maybe it may have gone through to the it may have infiltrated and contributing now as a base flow. So that recession part is basically representing that thing, okay.
Okay.
So now what is given in this question now? So regarding this, it is given that peak of 300 meter cube per second. So you may have idea now that yes, there is peak of 300 meter cube per second. So discharge, maximum discharge is given. Now it is also saying that this, what could be the shape of this hydrograph. So it is saying that it is just similar to triangle. Okay, so we have to consider the shape as triangle. And what is the width of this triangle? So we know that in the x-axis time will be there, so they are saying that it should be a 75 hours. So
Duration of rainfall.
yes, exactly, ma'am. Now we have q, we have time also. Okay, we also know that you can consider this catchment, and now it is saying that at the outlet where we are measuring, so it is contributing the water from 1500 kilometers square. So this catchment area will be around 1500 kilometers square. Okay, now you can you are also having idea of area. Okay, area is what? 1500 kilometers square. Now they are asking about, if the catchment area is this, then effective rainfall of the storm is, effective rainfall they are asking, effective rainfall. Effective rainfall is nothing, it is an excess rainfall. After subtracting the infiltration, how much it is going, that we have to compute. So excess rainfall they are asking. So any approach from your side? See, don't go with deeper details, because I just want to mention one thing, that when we are studying the hydrology, most of the time what formulas are there, they are basically related to what are the fundamentals we have studied in our up to 12th or maybe in graduations. So there is nothing serious in this question also. We know that if I am just saying that Q is given, okay, so Q is given, so Q what we understand by Q. So Q is nothing but it is a volume of water which have been accumulated at the outlet upon with the time, right? Now what about the volume? If we break out the volume, then what it will come up? It will come up as area into depth.
Depth of rainfall.
Yes, depth of rainfall, and depth of rainfall is nothing, it is an excess rainfall only. Got it? It is talking about the excess, because it is already saying that direct runoff hydrograph it is there. So how direct runoff will be generated? It will be generated only after receiving the excess rainfall depth only. Otherwise there won't be a direct runoff. So now you will be having a clear picture that how we have to approach in this question. So what you have to do, we already have area, we already we need to compute this depth of rainfall. Okay, this is an unknown. Also we also have Q, so correlate this, try to equate these parameters. So what you have to do, you have to write it as a Q equals area into excess rainfall depth upon time. Got it? Now try to figure out this depth. Or in other terms, you can also compute this by taking the entire area of this triangle. We can also get the volume. Okay, how we can, there is a second approach I am just mentioning here. If we multiply Q with time, if I take the area of this, see this graph, if I take the entire area of this, what will it give? It will give give volume only, volume of water which have been accumulated in the gauging side or gauging point. So for your reference, just a graph have been plotted. So discharge versus time, you can see this is a graph. Now try to figure out its area. So its area will be what? Half of 300 into 75. It will giving us direct value of volume. It will be giving direct value of volume. Okay, and that volume is runoff volume. Runoff volume. So see, total runoff have been generated. How we are computing this? So we are taking that area of this triangle. So we are getting this much of value. Ashish, try to figure out try to compute this value.
Total runoff. Just a minute.
बता दे क्या ले ही है ना यार ऊपर आज तो हमारा भी एक्स्ट्रा ले लो यार
0.575 3600.
अरे कोई बात नहीं तो हमारा भी ले लो यार वो वेट कर रहा हूँ आपसे
This is the simplified formula. Like using this, you can directly compute. So here, if we are taking Q and T together, we are directly getting the value of V. So now you are computing the area, right? So volume you have computed. This is the volume only, 40 point something, 40.5 into 10 to the power of 6. That will be equivalent to area into depth. Now if you want to compute this depth, you have to divide it by area. And now give me the value. Tell me the answer, that what is the depth. Don't go through the direct calculation because these calculations are done from my side. So definitely there may be a chance that these values may be wrong also. So that's why I want you to solve it parallelly. And if any difficulty is there, we can sort it together. Ashish, have you got the volume, runoff volume?
Just 0.5 into 75.
Ma'am, are you facing any difficulty in this?
Yeah, I get a different value, right?
Okay, what?
1,35,000. The
Okay,
total runoff 0.5 into 75 into 3,600. I get 1,35,000.
okay, wait a minute. Let me calculate also. Wait a minute. I'm also doing parallelly. So 0.5. Okay. There is a confusion. Don't. Yeah, just I mentioned. There definitely there could be an error also.
Yes, it
So
is
it should
one.
be 300.
Instead of 3600.
Yes. Calculate it. I'm
Yeah,
just
yeah, yeah.
calculating
Right.
right
Yeah,
now
yeah, no. It's okay. That's
because it is written 3600.
Yeah. The height of the triangle is 300, no? Right, the peak
Yes.
value.
Right.
so 0.5 into 75 into 300.
Exactly.
We got 11250.
Okay. Anything extra we given in the question? Okay.
It's 11,250.
Yes. definitely. So area of triangle, it will be giving a total volume. So yes, there should be a correction in this case. How much you are getting?
11250.
7,250. 11250. 250.
11250.
But
Okay.
we have to convert it into seconds, no? That it is in 75 hours. That is also there.
Okay, okay.
That also
That
we
is
have to do.
also,
There,
yes,
there.
yes,
I think
yes,
we
yes,
missed it.
right.
That's one more correction.
Right.
Then this is 260 into 60.
Yeah.
The,
So 0.75 into 75 into 3,600 into 300.
mhm. Yeah, we got it. 40.5 into 10 to
Oh,
the power
that's good.
6.
Yeah,
Yes,
yeah.
yes, yes.
Yeah.
Okay. So
Now
there
your
was
answer is correct.
some missing values. So what I have to do?
40.5 to 10 power 6.
That's good. What was left? So we have to multiply with 300, right? In this case,
Yes,
to got.
300 into 60 into 60.
Okay, so that is
Insert 300.
3600 is correct. Just only one thing is missing. That is 300. Okay.
Yes, yes.
Okay. No issue. Go ahead.
So we got 40.5 divided by total runoff divided by area. 40.5 divided by. Yeah, we got 0.0268 meter.
Okay, that's good. Now convert it into centimeter and you will be getting this answer.
Hmm.
Okay.
Yeah, 2.7 correct.
And Ashish, let me know the answers from Balamurgan side also.
Sure. Yeah, he calculated 2.7 correct.
Okay, that's good. No issue.
I get 2.7.
Okay, ma'am. Good. Okay. Now I am moving ahead now. Now the question is related to infiltration indices now. Okay. Before going to this, I just want to mention that two main infiltration indices we have studied so far. One is phi index, okay, and then another one is W index. Most of the time, while solving the problem, we usually follow phi index, okay, because it is very simple and it is easy to compute. Now you can see from this problem, so it is saying that the observed rainfall data for successive 10-minute period. 10-minute period in the sense what? That stopwatch is working like readings are taken at every 10 minutes of interval. So you can say 10 minutes, then again 20 minutes, then 30 minutes, then 40 minutes, so on it is going up to 80 minutes. And what they are noting, so they are observing the observed rainfall. Sorry, this observed rainfall intensity. Okay, so rainfall intensity, this is don't confuse with this, or maybe I'm wrong or something. Wait a minute. Observed rainfall data for successive, this is there. Okay, I guess this will be some correction will be there. Rainfall is there. This is a rainfall data. It will be in centimeter. It won't be in centimeter per hour. So it is given like this 43974. Okay, and now it is asking about the phi index. So we have to compute phi index. Any approach for this? Like you all may be aware of that hydrograph. Okay.
Hydrograph. We can plot the hydrograph.
Exactly, yes. So same thing we have to do here also. Firstly, we have to find out the intensity. Intensity will be in centimeter per hour, and then what we have to plot this with the time. Okay. But right now, actually, I don't know you people can solve it or not, but I'm moving ahead at present. You can see the approach. Okay, so here if we want to determine, if we want to quantify the phi value, this process can be done using trial method only. We have to follow a trial method in order to compute phi, because while we are observing the data, continuous data, so we don't have the actual method or actual procedure, or we can say direct procedure through which we can directly quantify the phi value. If I am saying that you are getting the infiltration rate or infiltration rate values, and you can compute correlate with the this phi index, then definitely it makes it is not making sense. Okay, because while we are computing the phi, definitely whatever the total rainfall or whatever the water or volume of water we have provided during the test, it will also be counted, and in total it is taken as phi summation of that. So in order to get this phi, approach is like we have to go for trial and error, trial and method. Okay, and this trial method will be followed till we get actual rainfall equivalent to estimated runoff. Means what? For actual for every assumed values of phi, now why I'm just saying trial method, definitely phi will be assumed. Now we will be assuming, but definitely there will be a logic related to that. Definitely it won't be like I'm assuming 1, I'm assuming 2. Definitely there should be a logic. So I will be telling you how we will be assuming that value, and we will be putting this phi value in this formula, and we will be computing actual runoff. So actual runoff will be computed like this, and you can see that given already, we already have been provided with runoff depth. So that is, we can say, estimated runoff. So from the data itself, they have given that estimated runoff. What could be the estimated runoff? Now we will be computing actual runoff at every assumed phi index value. Okay. Now from this picture you can see that how the phi index value will be considered. Okay, but this is not our graph. I will be showing you how our hydrograph will look like in the next picture. So this is the picture that have been drawn from that table. Okay, so you can see rainfall intensity have been computed which is varying with the time. Now follow this table. So what was the data which have been given? So time was given. Also, wait a minute. Rainfall, it is saying, I guess it won't be. Okay, it is rainfall intensity. There is confusion in this. It will be centimeter per hour only, but it should be a rainfall intensity. Okay. Ashish, be clear with this. Okay, this is a rainfall intensity having unit of centimeter per hour. Intensity was missing. There was some writing mistake in this case. So this rainfall intensity have been also given. Now based on this, we have plotted the rainfall intensity versus time graph. You can see. Okay, so for 10 minutes, 20 minutes, 30 minutes, 40, 50, 60, 70, 80, we have plotted this. Now can you tell me like at what time we are getting the highest rainfall intensity? At what time we are getting the highest rainfall?
30
Yes,
minutes.
you are right, ma'am. So at 30 minutes we are getting the highest rainfall intensity. That's good. Now at what time we are getting the lowest infiltration this rainfall intensity? Lowest.
70 I think. 70.
Okay, that's good. Yeah. So now what logic just I mentioned, there should be a logic in selection of phi. So whatever the phi value we will be assuming based on the lowest rainfall intensity we have. So here in this case you can see that lowest infiltration, this rainfall intensity is 2 centimeter per hour. So here we assumed phi as 2 centimeter per hour. Okay, and what we have did, we have computed the actual runoff, and how we are computing this actual runoff you can see in the table. Okay, so as it was mentioned in the question that data have been recorded successively, so it was cumulative data. Okay, cumulative data, not an incremental data. So firstly what we have to do, we have to take an increment at each time step. So we have computed the time increment, that is 10 minutes for every observation. Then that time have been converted into hours. So it is also same. Now rainfall intensity, we already have this data with us. Now what we are doing, we are now computing the effective rainfall hydrograph. And how we will be doing this? Rainfall minus infiltration. Infiltration in the sense phi index will be representing the abstraction only. So like for using the better word, infiltration should be substituted by abstraction, or maybe I can say losses, because phi is representing the losses, not an infiltration accumulation. So rainfall minus losses. Now try to see that whether you are getting this value or not. Effective rainfall, just I mentioned, effective rainfall will be what? Whatever the excess rainfall falling over the phi line, line what we have plotted, this will be entirely an excess rainfall only. Got it? And excess rainfall is nothing, it is an effective rainfall.
Okay, got it.
Got it?
Yes.
So you will be getting this effective
Yes,
rainfall. So for
217.
time of 10 minutes, you are getting, are you getting this 2 centimeter per hour?
Yes.
Okay, now once you get the effective rainfall hydrograph, in order to compute the actual runoff, we have to multiply it with time interval.
Time.
That means 0.167, and see the value whether you are getting this or not.
Okay, 2.16. Yeah, it's 333. Correct.
Okay, now likewise we will be computing for all the observed sample at different time interval, and see, after adding this we are getting 3.833. This is what? This is a actual runoff depth we have found. But what we have been provided, we were given estimated runoff approx, wait a minute, there is, okay, I guess there is a confusion in the words, like whatever the data they have provided, it is runoff from the catchment is 3 centimeter. Okay, okay, so it is considered as an actual runoff. Okay, and whatever we are computing, it is an estimated runoff. Don't get confused with this. Okay, now see the things, that actual runoff which have been given in the question, it is less than the estimated runoff. But what was our target? We are assuming the values of phi, and we are going for trial method, but we will stop where we will get the actual runoff equivalent to estimated runoff. Whatever the value we are getting, we are computing through following the data, it should match with the actual data. But in this case, actual runoff data, that is 3, it is less than 3.83. That is why we are going for the another other trial method. Okay, so trial second will be followed. Is it clear right now? Till now, is it clear?
Yes, yes, it's clear.
Ma'am,
Yes, yes.
Okay, good. Now again we will be taking a higher value of the previous case. Like in the previous case, we have considered this 70 minute data. So rainfall intensity at 70 minute we have considered in the previous case, but now we are going for next higher value. So next higher value is what? That is 3 centimeter. 3 centimeter per hour.
Yes.
So now we are taking rainfall intensity of 3 centimeter per hour, which was occurred at 10 minutes. Okay,
Mhm.
and now the same procedure will be followed, and see what we are getting. We are getting again a value of 2.667. Is it less or is it more?
Less. Less.
Okay, so now we are having estimated runoff less than actual runoff.
Mhm.
Got it? Any confusion till now?
No.
I just mentioned that logic should be clear. Logic is what?
Mhm.
Firstly, you have to assume the smallest rainfall intensity, and if you are going for next trial, then you have to take next higher rainfall intensity value, and so on.
Mhm.
Got it?
Got it.
Ma'am,
Got it.
is it clear to you? Ma'am, is it clear to you also?
Yeah, it's clear, sir. Clear.
Okay, good. So now, just you mentioned, Ashish, that we are getting a less value at one case, okay, like 2.67 when we are considering 3 centimeter, and when we are considering 2 centimeter, we are getting higher value 3.83. So what should be your logic now? What should be your logic now? Don't you think that now phi index value should lie between 2 centimeter to 3 centimeter now? Sorry, 2 centimeter per
Yes.
hour
Yes.
to 3
Yes.
centimeter
It
per
will
hour.
lie between 2 to 3 centimeter per hour.
Exactly. In order to fulfill this criteria,
Mhm.
now the value, whatever the phi index value will be selected, it should lie between 2 centimeter per hour to 3 centimeter per
Three.
hour.
Between 2 and 3.
Exactly. Now see the trial third case. So now again assumption have been taken by phi index equals 2.5 centimeter per hour, like mid
Mhm.
of 2 and 3, mid
Mhm.
of 2 and 3. Now you can see the computation again. This phi index value have been moved ahead now, above 2 and below 3, you can see. So phi here is what? That is 2.5 centimeter per hour. See the computation now. So we are getting the estimated runoff again. Okay, and now how much it is coming? It is coming, sorry, it is coming 3.250. Now tell
Mhm.
me whether this value is high or low as compared
High.
to actual value.
It's high.
Okay, again it is high, but yes, it is not that much high as compared to
Mhm.
first case.
Mhm.
It was coming 3.83 something, right? So now we are more closer to our answer now.
Approaching this exact value.
Yes, 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 right, yes. So now, Ashish, now I want,
So for a small, we need to go for a smaller interpolation.
okay, so what should be our target now? Whether we have to go ahead or we have to go below to this value 2.5, we have to take something 2.3, or do we have to
Lesser
take,
than 2.5. We have to go a little lower.
okay, if we take, like if we are taking, I'm just showing you one thing. If we are taking the smaller value, then what we are encountering, we are getting a higher value. Got it?
Mhm.
Oh, I'm
And if we are
sorry,
taking
sorry.
if we are taking a higher value, we are come up with smaller value, estimated runoff with smaller value. Got it?
So we need to go with higher values.
Higher
Exactly.
value. I'm sorry.
Yeah. So
Sorry.
we have to go ahead with somewhat related to 2.7, maybe 2.8, as per your convenience, because that is the only thing we can, because only 2 units we can go ahead or maybe below. Okay, but right now we are going with 2.7. Now see, if we are taking phi index as 2.7 now, so this phi index, this phi value is going somewhat ahead in the sense what, 2.5 to 2.7 now, means 0.2 centimeter per hour increment have been done. Now see the results. So we are seeing that actual runoff value is what we are getting, it is nearby to our actual value, actual runoff. Okay, so 3.017 centimeter. Any confusion? So now we are getting somewhat exact value which we were targeting while computing the estimated runoff. Got it? So what should be our final answer? Phi index should be 2.7 centimeter per hour, because if we are taking this value, we are satisfying this condition. Actual runoff should be equivalent to estimated runoff. Got it?
Got it.
Should I move ahead now?
Yes, you can.
If
Got it.
any I will suggest you to go and solve 1 or 2 problems related to this. If you are facing any problem or difficulty, you can tell me in the next session. Okay? I think there is nothing. It is just about a logic. You have to start with the smallest rainfall intensity value, then go next step, higher rainfall intensity value, and then try to analyze those trial methods, and in parallel,
Minimize the difference and come closer so that both are equated.
yes, right, ma'am, exactly. Okay, now the next question is, we have to estimate the total surface runoff from the catchment. Total surface runoff from the catchment, but for this case, phi has been also already given. So we don't need to go for this long process. We already been provided with phi value, that is 0.9 centimeter per hour, and we also have initial losses, that is IA, that is 0.6 centimeter. Mass curve of the rainfall duration 100 minutes is tabulated below. Like you can see the table. Okay, so the variation of rainfall depth with the time, it has been mentioned in the table. Now it is asking about the total surface runoff. So can you have any idea like how we can compute? If we are having phi, how can we compute the Q, that is total surface runoff? We have been provided with the total rainfall also. For time being, assume that P is total rainfall. So P is total rainfall we have been given, and also we know that what are the abstraction which can be there. So abstractions have been given, continuous abstraction, and it is in terms of phi. So if we are subtracting total rainfall with the phi index, we could achieve total surface runoff. Am I right?
Yes.
Okay. Now see this table. So this table represent the data that have been already given. So first column, data already given. Now, okay. So this, fourth column, this is also our data. Now see, this entire data, this was cumulatively recorded 0, 20, 40. We don't have idea that in between for fixed 20 minutes of interval, how much exactly rainfall have been occurred. We don't know. So that is why we are preferring this time increment column. Okay. So again, we are computing the time increment. So it is coming 20 minutes for each interval. Then we are computing the time in hours also. So just simply we are dividing 20 by 60. Then we already have rainfall mass curve data. So we are now computing the incremental rainfall depth first. So how we are doing this? So we are doing by just subtracting this. 0.8 minus 0, 1.8 minus 0.8, and so on. Now initial losses. So initial losses, how much it was given? 0.9 centimeter per hour. Okay. Now 0.9 centimeter per hour multiplied by delta T. Already we data have been mentioned that it is for 100 minutes. So firstly try to convert this 100 minutes into or maybe I'm not saying that entirely 100 minutes. It will be divided in different intervals only. how we are recording the data. So whatever the phi value we are having, 0.9 we are having, we have to multiply directly with delta t, that is the interval value. So delta t, how much we are getting, that is 0.33. Okay, so it will come this much value only. Ashish, compute this, whether we are getting this or not.
Just a minute.
We are getting na. Just I want to confirm initial losses.
So 0.9 divided by incremental time. 0.333.
It won't be don't divide that value na. We are computing in centimeter only.
Multiplying. Yeah.
We have to multiply that.
Yes, we got in 0.3. Yes,
Okay.
correct.
Okay, so you got that how we are computing the initial losses. So we are just multiplying the phi value with delta t, incremental time value in hours. Okay, and now we have incremental rainfall depth, that is r, and we also know that initial losses, that is cumulatively you can take phi value. So r minus phi, or maybe sorry, don't take it r, take it as p. Okay, this is a representation of rainfall for our case. So p minus phi, it will giving you a total runoff depth, okay, in each interval. So now you can get the idea that this runoff depth is nothing, it is a difference between incremental rainfall, that is p minus phi. So you will be getting the idea now. So 0.8 minus 0.3, it will be giving directly value of 0.5. Now add up all these values, you will come up with 2.7, and this is 2.7 centimeter. Okay, so total surface runoff depth generated is 2.7 centimeter. Okay. Okay.
Yes.
Any confusion till now?
No.
Okay. Now again there is a question. Wait a minute, how many questions are left now? 1, 2, 3. Okay. Wait a minute. Okay, we will be solving this last problem now. Okay, and the remaining question we will be discussing in the next session. Any problem?
Yeah, no problem.
Okay, so here it is asking about the computation of phi index. So phi index value we have to compute. For this case, it is saying that there is a direct runoff. You can assume it as like a hydrograph kind of scenario is existing now, and we are getting a direct surface runoff of 5 centimeter. So it is just representing total surface runoff equals 5 centimeter. Also, it is saying that average intensity is also given. So average intensity is what? Ashish, focus on this question. You have to answer here. Ma'am, also you also have to answer.
Okay.
Okay, so average intensity is given. Okay, so average intensity is how much? 3 centimeter per hour. Now what we want to compute? We want to compute phi. How we can do this? If we have average rainfall intensity, generally in general sense, what we understand by phi index? How we can get this phi? Is there any difference? There is certain formulas or maybe certain relation based on the differences we can get this. So if let's assume
If we are able to evaluate the total rainfall volume and the runoff volume, the difference and the duration of the rainfall, we can get phi index.
exactly, ma'am, you are right. So precipitation, total rainfall that have been occurred and as well as total surface runoff depth. If we have idea about these two parameters, we can directly compute this value. So now this is average rainfall intensity. Okay. So it is an rainfall intensity, but this average rainfall is occurring for entire 6 hours, like for the period of 6 hours. So this is at the rate of 6 hours. Now tell me the total rainfall. You can compute it easily now. Total rainfall. So it will be what? 3 into 6. Right? 6 3 the 18. Right? 18
18.
centimeter. Got it?
Hmm.
Yes.
So total rainfall is with us. Now we also have idea about total surface runoff. Now can we compute this? So 18 minus 5, it should be like that only.
13.
13.
Yes.
Let's see. This is also my approach only. So yes, abstraction is 13 centimeter, right? But phi index is what? Phi index will be in centimeter. It is representing a rate. So centimeter per hour. We have to compute like this. So 13 centimeter will be divided by 6.
Divided by duration of rainfall.
Exactly, ma'am. Right. So we are getting the direct value of 2.17 centimeter per hour. Any difficulty in solving this problem? Balamurugan, Ashish, kindly let me know. Balamurugan is replying.
Yeah, just a minute. Yeah, he replied 2.17.
Okay, that's good. Okay. So today I'm stopping here this session. Okay. Try to solve the problems related to these and okay. And if you are facing any problem, like there are few more numerical problems are left which are based on this infiltration indices only. So I guess we already discussed one or two problems which can cover your assignment part. I guess if it is not going, then we can discuss in the next session also.
Thank you very much, sir.
Yeah.
And just one request, please upload this one into portal so that we can use this to calculate our assignments. These slides.
Okay, these slides. Okay. Are you not getting
No,
access
no,
to these?
we got it, but I think we got it 1 or 2 days after. We request to just please upload at earliest.
Actually, in the last week itself, I just uploaded like after finishing this session,
Yeah,
after
yeah.
maybe
I could see it immediately.
Okay,
yes,
Uh,
okay, that's all.
on that
That's all.
night
maybe
itself.
there may be some reply from NPTEL team also. There may be
Sure.
that there.
Okay, thank you.
Yeah.
It's okay.
Okay.
Thank
We
you
will
very much.
we will
Thank you.
Thank.
meet in the next session.
Sure.
Thank you.
Okay.
Bye.
Thank
Thank
you.
you. Thank you
Yeah.
very much.
Okay. Thank
Thank
you.
you very much. Bye.
Yeah.